Hello. Today, we will take up another topic, which is upon phases of compiler design extensively. To commence with the topic of phases in compiler design. Firstly, let's just refer to the compiler. Compiler, it is a translator, which converts source code into the target code. Let's consider an example for this. Source code. Hash include studio.h. Int main. Print hello world. Return 0. We will get target code from source code is like this in the form of zeros and ones. Here, we are given a source code to print the hello world. It converts our entire source code into target code, which is understood by the machine, which is in the form of binary digits zeros and ones. In phases of compilation. A phase is a logically interrelated operation that takes a source program in one representation output and another representation. The compilation process is carried out in two phases, analysis phase and synthesis phase. Coming to analysis phase, it is machine dependent and language dependent. In the analysis phase it contains some of the analysis. There are 1. Lexical analysis, 2. Syntax analysis, 3. Semantic analysis. Next, coming to another phase of compilation is synthesis phase. It is machine dependent and language independent. It has 3 divisions in it. There are 1. Intermediate code generation, 2. Code optimization, 3. Code generation. Let us see the phases of the compiler flowchart. From this flowchart of the compiler we can see input from the first is the source program and the output from the last is the target program. Here, in between every phase is taking the input from the previous phase, which has the representation of the source program, and the output will be sent to the next phases in order. As we have already discussed, there are 3 analyzers in the analysis phase of compilation. So, let's discuss it inclusively. 1. Lexical analysis. It reads each statement of the source program line by line and then it is broken into a stream of strings called tokens. In general way, let us consider a simple expression or sentence. A equals B plus 10. Where A, defined as a letter in an alphabet, equals, defined as a equal to symbol, B, defined as letter in an alphabet, plus, defined as addition symbol, 10, defined as number. These all are set as lexemes. It is also called a scanner, as it reads or scans the source code. It identifies each lexeme and stores this information in the symbol table. Next analyzer is 2. Syntax analysis. It builds hierarchical structure or tree structure by taking input from the lexical analyzer. For checking syntax of source program. In general way, for example, A equals B plus 10. This can be structured in a tree format. That can be shown as, to get an equation. Consider from left to right. Then we will get an equation as A equals B plus 10. So, here syntax analysis is a second phase of compilation. Syntax analysis is also called parsing as the parse tree. 3. Semantic analysis. It is a phase which checks whether a phase tree constructed in a syntax analyzer is following rules or not. Means, it is the same as a syntax analyzer, but it only checks if the syntax analyzer is following the rules or not. Here, we will have the same example of a syntax analyzer. These are the 3 analyzers in the analysis phase of compilation. Next, we will be discussing 3 divisions in the synthesis phase of compilation. 1. Intermediate code generator. This phase generates an intermediate code of the source code which makes it easier to translate into the machine code. In general way, let's consider A equals B plus 10. This can be generated as we know A, E, I, O, U are vowels and remaining letters in the alphabet are consonants. So here, an example for an intermediate code generation is generated as A equals B plus 10 is an expression. In that expression for each letter it is assigned with a new name, that is, 2-digit is for 10. Consonant is B. Expression is B plus 10. A is an expression. Next phase is 2. Code optimizer. This phase removes unnecessary temporary variables generated in the ICG, intermediate code generation, phase. In general, consider A equals B plus 10. Here, 2-digit equals 10. Consonant equals B. A equals consonant plus 2-digit. That is, B plus 10. As it performs code optimization for the intermediate code, consumes less space and avoids wastage of resources such as CPU and memory. Length of the program is reduced here. Last phase is code generation. 3. Code generation. It translates intermediate code into relocatable machine code. In code generation, eventually it converts source code into target code. In a general way, consider A equals B plus 10. Here, in this code generation, by using move we are moving 10 into the memory named R1. That can be written as move 10 by storing into memory R1. Now, we are adding B with R1 and again storing it into the R1. That can be written as add B with R1 and storing R1. Next, we are moving by storing R1 into the A. That can be written as move storing R1 in A. The output of the code generation phase is the target code. In this way, the compilation process is done using the different phases of the compiler. Next, coming to the symbol table. Symbol table, it is a data structure which contains information about identifiers, array names, subprogram names, parameters etc. For example, consider A equals B plus 10. Here, A is a vowel. B is a consonant. 10 is a constant. Equals is a symbol. Plus is a symbol. Next, error handler. It is used to detect the errors then report errors in the source program during different phases. In general way, consider A equals B plus 10, as it can be done with any phase in the error handler. Let's take the lexical analyzer phase. To be considered as, here, A is a letter. Equals is an equal to symbol. B is a number. Plus is addition symbol. 10 is a letter. Here, B is not a number, it is a letter. And 10 is not a letter, it is a number. So, by using an error handler it detects the error. And it solves the error. Now, by discussing the phases of the compiler, let us consider an example by converting the source code into target code. Let us consider A equals B plus 10, which is sent to the lexical analyzer. Now the lexical analyzer considers it as an input and it is divided into lexemes. Those lexemes are named as tokens. They are ID1 equals ID2 plus ID3. Here, ID is an identifier. So, this expression is sent to the syntax analyzer. It takes as an input and builds a hierarchical structure or a tree structure by following the left to right approach, and the node contains the operator and leaf contains the operands. So, here ID1 equals ID2 plus ID3. Again, this is sent to the semantic analyzer for checking whether it is following rules or not. So, it checks and again it sends to intermediate code generation. Makes the code easier to translate into the machine code by assigning a temporary names as T1 equals ID3, T2 equals ID2, T3 equals T1 plus T2, ID1 equals D3. Then, intermediate code generation is sent to code optimizer. It takes input from intermediate code generation and it removes unnecessary temporary names and reduces the length of the program. So, T1 equals ID3, T2 equals ID2. It equals D1 plus D2. Next, it sends to code generation. Now, it performs by moving ID3 into the memory named as R1. That is, move ID3, R1. Then adding ID2 with R1 and again it is stored into the R1. That is, add ID2, R1. Again by storing it into R1 it moves the ID. That is, move R1, ID. Well, that's the end of today's topic. Along with the video explanations, we offer notes, mind maps, infographics and more to all the subjects from your syllabus. And also career guidance programs from current working IT professionals. And many more to our supporters. To join our supporters community, use the subscription link given below. For more topics from your syllabus, please visit our website given in the description. If you like the explanation, press the like button and rate us from 1 to 5 in the comments section below. For getting updates on any video we posted, please subscribe to our channel and press the bell icon. We will be back with another concept soon.